So, like, for example, if you have a concert or something and you charge $2 per ticket for the concert, then lots and lots of people will probably come because it's only $2. So if they want to hear you, the cost is not going to prohibit them from that. However, you're not going to make as much money because you only charge $2 per person. On the other end, maybe you charge $50 per person. At that point, you might be getting to the point where people aren't going to pay $50 to come hear you sing. So now you're not going to make as much money. So this equation is going to give us the profit that you make when you charge X amount per unit. So we can, now the market study part that comes up with that equation would be difficult to do, but if you can come up with that, then that's valuable information, so you know what the perfect price point is where you can make the most money, because that's the reason that they don't charge, just $5 for concert tickets, because they know they can charge a lot more and still fill up whatever coliseum that they're wanting to sell out, right? And then sometimes, maybe if they see their crowds are dwindling, maybe they might lower ticket prices so they can get more people there. So let's use our calculator for this one. We could do it by hand. It wouldn't be terrible, but let's use our calculator just so we get a little more practice with that calculator. And when I do these problems, you can do it one of two ways. So we want to take the derivative of this equation so that we can do a sign line with that derivative. So to do the derivative, we'll do F3. Differentiate, we're going to type in our equation. What have I done? Oh, it's just messing up. Do not want that one. Just use this one, but it's messing up. Let's see if it'll work now. Okay. Alright, so let's see if I can get it to work now. Whenever we differentiate, you have to put comma, x, and then close the parentheses after the end, and it's still messed up. Implied multiply. I think it's probably right here where we've got that x next to that parentheses. Sometimes it doesn't like that for some reason. Yeah, I think that was it. So, I'm not really sure why it can't deal with that, but at other times it seems to work fine, but so if you ever get that error, implied multiply, look for somewhere where you put two things right next to each other and assumed it was multiplication, that you can fix it by doing this. So our derivative here, so dp dx is going to be 25 over the square root of x minus 0.5. And we could have done that without the calculator, but I just like to get a little practice with this. So once we find derivative, what do we look for next? We look for the zeros of that derivative, right? Did you close your parentheses for your square root? You've got 2 there.
Yeah.
Did you open a parentheses before your 50?
Yeah.
Did you put parentheses after your comma X? That's it. You gotta have one there on the end.
Okay. Yeah.
Did you put comma X and close your parentheses at the end?
I always forget the comment.
Yeah. When you take a derivative or something like that, or if you're solving an equation, you got that comma X so it knows what it's taking the derivative with respect to. I'm actually going to do this. I'm going to go to y equals, and I'm going to, actually, I can even do this if I want. Go back to the home screen. I can go up here, I can copy this. It's not that difficult to type in, but you could copy it. And I'm going to go to y equals, and I'm going to paste that there. The green button, and then the up arrow there. Or you can just type it in. And I'm going to look at the graph of this. I cannot see it very well right now. I know that for my window here, X is my price, so I really don't need to see negatives there, because even if there were negative values that were maximum or minimum for this solution, it wouldn't apply to the situation. And so I don't really know where to go. I'm going to go like 50 right here for right now in his graph. And I'm looking for where this crosses the x-axis. This is still not enough, so let's go to, I guess I'm going to go 200. That'll be enough. No, it's not. Let's go 3,000, just because I know what the answer is. And it looks like it just sort of disappears. The other thing we can do here, and this one maybe it was not the best one for us, just go straight to the graph. The other thing we can do here is we've got 25 over the square root of x minus 0.5. We can set that equal to 0. So 25 over the square root of x equals 0.5. We would multiply both sides by the square root of x. So 25 equals 0.5 square root of x. We would divide by 0.5. So it's going to give us 50. And then we'll have to square both sides, so we get 25. 100 equals x. And if I look at the graph here, I know over here before 2,500, I know that it's positive. And I'm not certain over here, but I imagine that it probably switches to negative. It's really hard to see because of our y-axis. We could go like to our window and maybe make this go from just like -1 to 1. And I bet we could see a little bit better that it actually crosses. You can see if you zoom in some there that it does actually cross right there. So we have a negative. So that tells us this is the maximum. So whatever this is that they're selling, the maximum occurs at x equals $2,500. In this case, 0 is a critical number because zero would give you would make this undefined because it's in the bottom. Critical numbers either make the derivative zero or undefined. So so that could be a critical number. Also, just because of the situation, I know I'm not going to have negative values because people don't pay you to take stuff from them normally. You know, if you're selling something, you don't sell it for negative values. So because of the situation, you wouldn't want to include any negatives for this. Now, this is not the profit. This is how much you're selling each item for. So say it's some sort of fancy TV or computer or something. This is how much you're selling each one of those for. Yeah. Yeah. Yeah.
I mean, if it's like an ACC
I think the good seats get like that.
Duke, you would see.
Yeah. Especially when it's at Duke because Duke has such a small stadium. It is.
I don't know, man. If I had enough money to even go to that game in the first place, yeah, like if you were just like,
I would really have to have money to throw
if you were
around.
like a diehard
I'm
Duke
nowhere
Carolina
near
fan,
having the amount of money.
I really don't even care about this.
Yeah.
I don't really watch sports either.
I feel like my grandpa, he is a fairly wealthy man. He owns a sawmill, but he was not rich growing up. He was very poor growing up. He has a hard time with things,
Giving up money.
you know, even though now he does have money and he does spend money on some things. He likes old cars and tractors and stuff like that and guns, but there's some things he just cannot do. You know, if a tie costs $50, he will not buy it, even though he could if he wanted to without it really hurting him at all, you know.
That's a good mindset.
But, I feel like I have probably, although I've probably lived a fairly privileged life compared to many, I would probably feel like that even if I did have the money to spend nearly $3,000 on tickets. I'd have a hard time doing it. I'd have a hard time doing it. And I think it's all sort of relative to what you're used to or how you grew up. Even if maybe now you might have the money. So, but yeah, that'd be a lot of money for tickets. So this is not the profit. If you want to know the profit, you need to plug this back into the original equation. Just out of curiosity, I'd like to plug that in to see.
What kind of business is having an event that you have to take $100?
I don't know. It may be something they're selling though.
Maybe it's like
It might be a
car
computer. Yeah, it might be.
Maybe there's some security.
Something like, yeah, it could be something like that. Something that's pricier, obviously.
Because I'm trying to think of stuff that people need that's $2,500.
And my calculator's messed up, so I can't.
A pool's probably more than that. Like a underground.
Getting it put in would definitely be a new pool liner would cost you about this much, I think. Because my grandpa has a pool, and whenever he had to put a new liner in his pool last year, my mom takes care of the pool for him, and I think it was about $2,000, which is a little less than I thought it was going to be. And that's installed and everything, so, but he was also really not happy about having to spend that money on the liner for the pool. He told us all he was going to have to sell a tractor to pay for the pool liner, which was not true either. He could afford the pool liner, but he's 92 and he grew up very poor, so yeah.
I guess it's good that he's careful.
Yeah. Yeah. So, all right, so second example. A company estimates that the cost of producing X units is C equals 800 plus 0.04X plus 0.0002X squared. Find the production level that minimizes the average cost per unit. So in this case, our equation, they've done some sort of complicated study. They have decided that this is how much it costs to produce a product. So you want to minimize that cost. Every little corner you can cut without compromising quality can help you whenever you're talking like large-scale manufacturing sort of thing. So, let's see. We'll use let's just take our derivative by hand on this one, especially since this thinking calculator is being hateful. And this is also pretty easy derivative, so dc dx would be 0.04 plus 0.0004x. So this is really you might need your calculator to calculate some of this, but it's pretty simple derivative. We're going to set that equal to 0 to find those critical values. So we would subtract that 0.04, so 0.0004x equals negative 0.00. Oh, no. I need to adjust what I've told you here. I've jumped into this way too quick. Thought this was not working out because you're going to get a negative number for that. A custom company estimates that the cost of producing X units is this. Find the production level that minimizes the average cost per unit. So, some of your costs are fixed costs here. It does not matter how many units you make. So, like, if you have a factory and you're setting up to make whatever item you're making, it's going to cost you a certain amount to set up the machines and buy the machines and get them ready, even if you only make like one computer or one iPad. All right, so that $800 is a fixed cost. So if you only made one, it would be really, really, really expensive. If you wanted to make your own iPad and you set up all the machinery and stuff to make your own iPad, just like you would on regular production line, then I can't even imagine how much that would cost, right? But if you mass produce it and make it, make a bunch of them, the cost should go down. However, at some point, you're going to reach the point where maybe you're having to pay your workers overtime because they're having to work so much, or you're having to fix a lot of your equipment because it's breaking, because it's overused, where the cost may go back up. So we're looking for the cost per unit. This C right here tells us the total cost. So if we want to know the cost per unit, what we're going to have to do is we're going to make us an equation. I'm just going to call it Y. And it's going to be 800 plus 0.04x plus 0.0002x squared. That's just total cost, right? But to find your cost per unit, you have to divide by the number of units you're producing, which in this case is X. We can use the quotient rule, but I think it is easier in this one to do a love connection here. Okay, so you would have 800 x to the negative 1 plus, then you're just going to get 0.04x, no x at all, just 0.04, plus 0.0002x. And then it's a little easier to take that derivative. So whenever you take your derivative, you would have negative 800 x to the negative 2. The 0.04 is just going to go away, plus 0.0002. I'm going to write this back this way, negative 800 over x squared plus 0.0002. we need to set that equal to 0. 0 would be a critical value for this because it would make this undefined, but we need to find the other one, which is probably going to be our answer. So 0.0002 would equal positive 800 over x squared. Multiply both sides by x squared. 0.0002 x squared equals 800. We divide 0.0002. And so x squared equals 4 million. I think mine gave yeah, and then 4 million, and then we'd have to take the square root of both sides. Hold on. Oh. 2,000. So for this particular instance, your cheapest price per unit would be if you made 2,000 of whatever it is that you're making. If you start making more than this, it's going to cost you more per unit. If you make less than this, it's going to cost you more per unit. This is your absolute minimum cost per unit. If you've seen in the news lately, I know Tesla's trying to make the Model 3 or whatever that's supposed to be more affordable at least, but they've really had a lot of production problems because getting into mass-produced cars is really, 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 really difficult. So their model, yes, it is actually one of the most American-made cars, I think. But it's super high. It's super high end. So they can afford to make a lot of their stuff in the U.S. They're having trouble like making an affordable model of the car though, because their Model 3 production, I think it's been way behind. It's very, very, very difficult to get into like the mass produced cars.
Super high tech.
I'm sure they've got some pretty cool jobs, but it's very difficult to mass produce something. It's like if you want, like let's say that on the Ford F-150 there's something that's kind of defective. People don't like it. They don't like something about the way this button works or something. But changing that, like they might keep it for several years after they already know people don't like it, because changing it is really difficult because all their machines are already set up and changing this piece means they got to change their suppliers. I know that my brother-in-law works over at the glass plant, and they're like constantly under a crunch because they can't get behind with the car companies they sell to. Because if they get behind with the car companies they sell to, then Ford can't make any F-150s because they don't have any back glasses for them, and you can't make a truck without a window in the back. So all of their like producers have to be ahead of them, and if they get behind, then they have to shut down production. And it's like that with all of the pieces that come together to be put together. So it's kind of crazy what goes into like mass manufacturing, especially like big complicated things. When you're doing something like small little toys and junk that they make in factories in China that are easier to make, it's not the same, and there's not the same demand. But when you're talking things like cars and things with multiple moving parts, it's incredibly difficult. But very interesting. Yeah. I mean, like if the glass plant, because my brother-in-law, like he will have to like work weekends sometimes, go in the middle of the night sometimes, because he, for a while anyway, he was about the only one that, besides a couple others, that like could fix the machine, one of the machines that has a lot of the robots in it. They were trying to train some other people to do it, but they just weren't catching on very well, and so they'd call him when things weren't. But I think they're doing better now, because I think they might have. Well, I know that they hired somebody else that was sort of like his assistant that could do a lot of work too, and then he cut the end of his finger off. I don't know if he's came back to work yet, but they're constant like you would think working at the glass plant making windshields really not something you get like under the gun about, but they have to be like so many weeks ahead. I can't remember. I know they make some stuff for Toyota. I know they make some stuff for Ford. Like they cannot get behind, because if they get behind, then Ford has to shut down their operations. And if Ford has if Ford has to shut down their operations, then they're going to like charge the glass company for holding them up like these big amounts, and then like it's so like if they get behind, it's a big deal. They have to try to stay ahead. And they don't make I don't think they make the glass there. They're just cutting and tempering the glass. So like, I'm sure it's sort of the same thing. Whoever is supplying them with their glass, they've got to have glass to make.
The robots that they use are like real, just complicated. All this stuff.
I mean, I'm sure
robots can do
creating. Yeah, I'm sure creating those robots is very complicated, and it's definitely complicated enough that not just anybody can do it, because they were calling my brother-in-law in all the time. But, like, I think operating them is something lots of people can be trained to do.
Better, but I don't know if it's true, because I saw it on, like, Instagram and stuff. There was, like, this thing where it was, like, some AI or something killed, like, 31 lab technicians in Japan. Did you see that too?
I know. I feel uncomfortable about all of the AI.
That reminds me, I need to tell Roomba to vacuum for me right now, because I got one for Christmas, and I can just go to my phone and say clean, and she goes and vacuums my downstairs, and then goes back to her little station.
So that little tiny circle thing.
I think I'm gonna love her.
So super cool, but I heard a story about this dog. This person had one, and it had a dog, and the dog got sick, and the Roomba like spread the dog.
This happened to my brother. Yes. Yes. This happened to my brother as well. If you have a dog that's going to poop in the floor in the middle of the day, you do not want to turn your Roomba on. But I don't have a dog, so.
So you can just.
Yesterday we were out shopping, and I told her to clean for me, and she vacuumed my whole downstairs and went right back. The first time I tried her, she got stuck under the couch, so I put the little laser thing there so she won't go under the couch anymore. So I did not get the super like expensive one. I got the like lower end one.
My little cousin, she's really small, and she'll like ride on the Roomba. She'll just sit on it.
Henry, we've like threatened him that he cannot touch Roomba, so he just goes up to it, looks at it, not touch. Then I'm sure he's going to decide that he needs to touch it one day.
Well, River, she doesn't get on it herself, but some people will like put her on there. In the room will be like.
I've seen dogs ride on it.
Yeah. Our cat might be riding it around. I don't know. But okay, so I don't really like all the artificial intelligence unless they can figure out one that will clean my whole house for me while I'm going to work. Then I'm for it.
I need a robot that will put things up.
Yeah, I mean, what I need my robot to do is much more complicated than vacuuming, although it is nice. Yeah, I need to fold clothes.
Yeah, but they're really, like, robots are really smart, but they also don't have a free thinking ability. That's the thing. So how can they think for themselves anyway?
They don't, but whatever you program them to.
That's what I'm saying. So if you program them to always obey you, then they can't.
Right, but you program them. Artificial intelligence is where you programmed them where they can learn things, sort of.
Yeah, that's
Like Siri is supposed to learn your voice. You know, like the way you say things.
I'm doing English, guys, so it sounds like Jarvis from Iron
Yeah.
Man.
But like I think the thing about artificial intelligence is like it can kind of learn things, so you might not have programmed it.
To learn.
You programmed it to learn, but you didn't know you were telling it to learn this.
Yeah.
Maybe.
Maybe it should learn.
I don't know a whole lot about it. It seems pretty complicated. So. Yeah, in movies they're scary.
Then the Avengers.
Yeah, Avengers.
All right.
Yeah.
Okay, we've done one like this, but let's do this one as well, because these problems, I think, are like coolest application of this. So, a power plant is on one side of a straight river that is 500 feet wide. A factory is 3 miles downstream on the other side of the river. It costs $5 per foot to run the power lines over land and $8 per foot to run the power lines over water. What is the most economical path for the lines? So we've done some problems sort of like this. This is like the rowboat problem, where you can't row as fast as you can walk down the beach. So we have a river, and this river is 500 feet wide, and conveniently it's 500 feet wide all the way down the river, and we know exactly all this stuff. So we've got our power plant is over here. And then 3 miles downstream on the other side, we have our factory. So, kind of like the rowboat problem, the shortest distance would definitely be just to go straight from the power plant to the factory. But you're going to have to go completely over water to do that, which is more expensive per foot to do. If you decide that you want to go down here, all the way down the 3 miles down the river and just go straight across the river, that will decrease the amount that you have to cross the river, but it's also going to be the longest path that you could possibly take. So there's probably something somewhere between where if we went downriver and then across at an angle like that, that's probably our shortest amount. But we must do some math to figure out for sure. So I'm going to call this right here, which part would be easier to call X? It's going to be easier, I think, to call this part right here X. Also, we need to change this 3 miles to feet because it tells us the cost per foot. So 5,280 times 3.
Oh, I knew it.
Got 15,840. So this 3 miles right here is 15,840 feet. So if this part right here is X, this right here is 500. Oh, not 5,000, 500. Okay. So this part right here, we could do Pythagorean theorem to find this length. That's our over water distance. So x squared plus 500 squared equals the distance squared. So we would square root both sides of that. So that distance right here is going to be the square root of x squared plus 500 squared is going to be what? 25 with 4 zeros. And then what would we call this section right here?
3 miles is 15,840 feet, so that'd be X.
So we would have, for our cost, it costs $5 to run the line over land. So it would be 5 times 15,840 minus X. And then $8 to run this over water. So 8 times the square root of X squared plus 250 here. So this is our cost equation. We could do this by hand, but let's use our calculator. Because I don't want to spend a lot of extra time with this. So if we take the derivative of this, sure you put your comma X in your parentheses at the end. And we get dc dx to be 8x over the square root of x squared plus 250,000 minus 5. Solving this for x is possible, but not that easy to do. So what I would do, if you can graph this, if you know what range you're in, which we do, let's just go ahead and graph it. So let's go up here. Let's copy this. And let's go to y equals, and let's paste. No, y didn't work. Alright. Okay. Alright, so we're going to have to change our window to be right. So we're going to go from 0 to, what is the biggest x that we could have? What's the longest we could possibly go that would make any sense for this problem? 15,840. So, well, yes, total distance, yes, but that x is just that 15,840. So, I'm just going to go like 16,000 right here. And have you guys used Zoom Fit much? I know my x's are right. I have no clue what my y's really need to look like here. So what I'm going to do is I'm going to get the x's to where they should be, and I'm going to graph this. And I actually might be able to see it just fine. It's looking like I can see it okay. It probably depends on your y coordinates. I actually can see this pretty well right here. But if your x's are right, if you do F2, which is zoom, and you do fit, which is down there at the bottom somewhere, A, it'll keep your x's the same, but it makes your y's show up so that you can see everything. Although,
so we're looking for where it intersects X.
Yep, so we want to look where it intersects that x axis right here. Which we are going to find just by finding that 0. So that is F5, number 2. And 0 here. Upper bound. And we get x equals 400.32. And we see that's where the graph changes from negative to positive, so that would be a minimum point there. So we would, if we were this power plant, we would want to go most of the way just along the land, but right here, this would be about 400 feet. That X value would be right there. So we would go like 15,440, more or less, down land, and then we'd go across at a little bit of an angle. Of course, if water was more expensive or less expensive, then that would change where that value would be at.
So, for this problem, would you say, would you need to spell it out and be like, you need to go approximately
As long as you have a picture for me, you do not have to, as long as X is labeled and you show me what that is here, then you don't have to give any extra information. But if you don't have a picture, or if your picture is not labeled well, you would need to spell that out. Okay. All right. Questions? All right. I've got some problems that I want us to look at from the book, and some of them are kind of like these problems, and a few of them may just be sort of different. So, from the book, we are going to do page 264, and we'll have 27, 41, 46,